Hey guys, so as promised, we're continuing the IGCSE mensuration questions. We're now on the hot questions, which are the most advanced questions where students struggle the most. So if you're someone who's new to this channel, I started this series where I did different levels of mensuration questions, starting with the mild, which were the easy ones. Then we did the spicy ones, which were the medium ones, and then advanced hot ones. So right now we're at the hot ones. So these questions will greatly help you in understanding mensuration and make you understand how to solve these questions and how to correctly apply the formulas when needed. If you're someone who's still struggling with the mild ones and the spicy ones, I'm attaching the link above, and you can check those questions out and develop better understanding of your basics. So let's start with the hot questions now. Question 11 says find the size of an exterior angle for a regular polygon with 18 sides. Exterior angle has the formula of 360 divided by your number of sides. So we do 360 divided by 18, and that is going to give us 20. So that is the exterior angle of a regular polygon. Then part B says in a triangle ACD, B lies on AC, and E lies on AD such that BE is parallel to CD. AE is 5.2 and ED is 2.6. Calculate BE. So this is a clear case of similar shapes where triangle ABE is similar to triangle ACD. Triangle ABE is similar to triangle ACD. So we can easily find the scale factor by which the lengths are enlarging. So we can do 5.2 divided by 5.2 plus 2.6. That would equal to BE over 6.75. So 5.2 plus 2.6 is 7.8. So 5.2 divided by 7.8 times 6.75. So 4.5 centimeters is BE. That is your answer. Part C says two solids are mathematically similar. The smaller solid has height 2 centimeters and the volume of 32 centimeter cube. The larger solid has a volume of 780 centimeter cube. Calculate the height of the larger solid. So once again, similar shapes. So the ratio of the lengths being cubed equals to the ratio of the volumes. So we have the height of the smaller solid. So 2 over x cubed equals to 32 over 780. So that's 8 over x cubed equals to 32 over 780. X cubed is going to equal to 8 times 780 divided by 32. That's going to be 195. Then we take the cube root on both sides. So x, which is the height of the largest solid, will be 5.79. So that's your answer. Part D says PQ is parallel to RS. PNS is a straight line and N is the midpoint of RQ. Explain giving reasons why triangle PQN is congruent to triangle SRN. So if N is the midpoint of RQ, that means NR is equal to NQ. So NR is equal to NQ. And we also know that alternate angles in parallel lines are equal. So that means this angle is going to equal to this angle. And this angle is also going to equal to this angle. So angle QPN is equal to angle RSP. Also, angle PQR is equal to angle SRQ. these two angles are vertically opposite, so they're also going to be equal. So angle QNP is equal to angle RNS because vertically opposite. This one was alternate. So as you can see, all three angles are the same. That means the lengths are also going to be the same. Thus, it's a congruent triangle. And the congruency rule that we're using over here is angle, side, angle. Because angle Q, side NR, side QN, and then angle N. So angle, side, angle. That proves that they're congruent. Question 5 says a diagram shows a water trough in the shape of a prism. The prism has a cross section in the shape of an isosceles trapezium. The trough is completely filled with water. Show that the volume of the water in the trough is 206.4 liters. So to find the area of the cross section, which is trapezium, we use 1 over 2 times height, which is 40, times sum of parallel sides, which is 50 plus 36. And that gives us 20 times 86, which is 1,720 centimeters square. Then for the volume, if you notice, the length is given in meters and the area is in centimeters. So we do 1,720 times 1.2 times 100. 1 meter is 100 centimeters. So we're converting the 1.2 meters into centimeters by multiplying by 100. So that is going to give us 206,400 centimeter cube. So in liters, 1 liter is 1,000 centimeter cube. So for this, we divide this by 1,000. And that is 206.4 liters. This is exactly what the question was asking us to prove. Part B says the water from the trough is emptied at a rate of 600 ml per second. Calculate the time taken in minutes and seconds for the trough to be emptied. So we just found out that the volume of the trough was 206.4 liters. Now they've given the speed in milliliters. So 1 liter is 1,000 milliliters. So in milliliters, it's going to be 206,400 milliliters. Time is going to be, rate is your volume divided by time. So for time, we do volume divided by rate. So 206,400 divided by 600, which is going to give us 344 seconds. They want the time in minutes and seconds, so we divide 344 by 60. That's 5.73 recurring. So that's 5 minutes. And 0.73 recurring gets multiplied by 60, which is 44 seconds. So 5 minutes and 44 seconds is our answer. Then part C says all the water from the trough is emptied into a vertical cylindrical tank. The depth of the water in the tank is 84 centimeters. Calculate the radius of the tank. So 206.4, the water in centimeters, right? So volume in centimeter cube was 206,400 equals to pi r square h. So radius is what we need to find, and depth of the water, which is the height, is 84. So that means we're going to divide this by 84 pi. And that is going to give us 782.13 to r squared. Take the square root on both sides. And r is going to be 27.96, which can be rounded to 28 centimeters. That is your radius of the tank. Then it says the tank is 60% full, calculate the height of the tank. So if it's 60% full, that means we're going to do 206,400 equals to 60% of the volume. So that's 60 over 100 times pi r square h. So radius was found to be 28. 206,400 over 6 over equals to 6 over 10 times pi times 28 squared times height. So that's 6 times pi times 28 squared divided by 10. That gives us 1477.81 times h. So then we divide these two to find the value of the height, which is going to be 139.67 centimeters. So you can round that to 140. So 140 centimeters is your height, or even keep it as it is. Either way, it's correct. Part B says a steel rod AM is placed inside the empty water trough as shown in the diagram. A is a vertex at the base of the isosceles trapezium, and M is the midpoint of the top edge on the opposite face. Calculate the length of the steel rod AM. So to calculate the length of the steel rod AM, since M is the midpoint, so we draw a straight line over here and connect A with this. So if you notice, we have a right angle triangle over here. This entire length is 36, so half is 18 and 18 over here. Opposite sides are equal, so 1.2 meters in centimeter is 120 centimeters. So this is also 120 centimeters over here. They want the length of the rod. So first we need to find the base of this triangle. We know the height, which is 40. $14,724. We square root both sides. So x gives us 121.34 centimeters. So now using the top triangle, which is also a right angle triangle, I'm going to find the hypotenuse. So AM squared is equal to 121.34 squared plus 40 squared. So 121.34 squared plus 40 squared is 16,323.39. 323.39. Square root both sides. And AM is equal to 127.76 centimeters. So you can even round that to 128 or leave it as it is. That's your answer. Question 5 says ABCDEFGH is a regular octagon with sides of length 6 centimeters. The diagram shows part of the octagon. O is the center of the octagon and M is the midpoint of AB. Show that angle OAM is 67.5. So for that, we know that in a regular polygon, all sides are equal. So this is 6, AB is 6, so this is 3, 3. This is also 6. And interior angles are also the same. So to find this middle angle over here, we know that it's an octagon. So that means if we divide the shape into equal triangles, it's going to be 8 equal triangles. So we divide 360 by 8 to find the angle in the middle, which is going to give us 45 degrees. So this angle is 45 degrees. They want us to find angle OAM. So these lengths are also going to be equal because it's a regular polygon. So for angle OAM, we do 180 minus 45 divided by 2. So that gives us 67.5, which is exactly what the question was asking us to prove. Then it says calculate the area of the octagon. For the area of the octagon, if we calculate the area of one triangle, we can times it by 8 to find the area of the octagon. So for the area of the triangle, we can see that we have the angle over here. We don't have these lengths. We don't have the height, but we can find the height. Because if we split the triangle into two right angles, which is already done in the question, this angle over here is going to be half of 45, which is 22.5. So we have the opposite. We need to find the adjacent. We use tan. Tan of 22.5 equals to 3 over OM. So OM is going to be 3 divided by tan of 22.5, which equals 7.24 centimeters. So area would be 8 times 1 over 2 times the base, which is 6, and the height is 7.24. Once again, we're multiplying the area of one triangle by 8 to find the area of the octagon. So 6 times 7.24 times 8, then divided by 2. So that's 173.8 centimeters square. That is the area of the octagon. Then it says find the area of the circle that passes through the vertices of the octagon. So if it's passing the vertices of the octagon, let's draw a representation of that. So octagon has 8 sides. So 1, 2, 3, 4, 5, 6, 7, 8. So this is basically an octagon like. Now the circle that passes through the vertex of the octagon, that means it's not the boundary. So if you notice, your radius of the circle is going to be this length over here. So if we go back to the triangle that we were dealing with in the previous case, we said this was 3, this was 22.5. This was a triangle. Now we need to find this length, the hypotenuse. So we have the opposite, we have the angle. So now we'll use sine of 22.5 equals to 3 over x to find the radius, x being the radius. So 3 divided by sine of 22.5, which gives us 7.84. That is the radius. So area would be pi times 7.84 squared, which is going to give us 193.1 centimeters square. So basically, this is your x. This is 3. This is 22.5. This is the triangle that we're dealing with. So we found the length of x, which is basically the radius of the circle, because it's coming right from the center and going towards the vertex of your octagon. And the circle is passing through the vertices, so that means it's at the boundary of the octagon. So that is why we use x as the radius. We find that using SOHCAHTOA, and then we just simply put that in the area of the circle formula to find the area of the circle. Then part B says the diagram shows a horizontal container for water with the uniform cross-section. The cross-section is a semicircle, and the radius of the semicircle is 0.5 meters, and the length of the container is 4 meters. Calculate the volume of the container. So to find the volume of the container, we need to find the area of the cross-section times it by the length. So volume would be pi r squared over 2 times 4. Radius is 0.45. So pi times 0.45 squared over 2 times 4. And that gives us 1.27 meter cube. Then it says the greatest depth of the water in the container is 0.3 meters. The diagram shows the cross section. Calculate the number of liters of water in the container. Give your answer correct to the nearest integer. The entire height, or like the radius, this was given as 0.45. So that means this is 0.15. This part over here at the top. Okay, so first we need to realize that if we connect these 2 points are also the radius, because they're coming from the center and going towards the circumference. So if we remove this part over here, so this length in the middle is 0.15 and this is 0.45. So what we can do is using this, if we highlight this triangle over here, this is a right angle triangle. So we have the height, we have the hypotenuse, we need to find this angle. So find this angle, we have the adjacent and the hypotenuse. We use cos theta. So cos theta equals to adjacent over hypotenuse. So that's going to give us, then we find the cos inverse of this. So cos inverse of 0.15 over 0.45 equals 70.53 degrees. So now we can find the area of the sector and then subtract the area of the triangle from it to find the area of the cross section where the water is present. So this is very similar to a question that we have done previously in this video. So area would be, actually shaded area, let's call it that. Shaded area would be 70.53 times 2, which is going to be the area of the sector. So 70.53 times 2 over 360 times pi, r is 0.45 squared minus area of the triangle 1 over 2 times 0.45 squared times sine of 70.53 times 2. So let me just find that. That's 141.06. So 141.06. So that's going to give us, I'm getting 0.1856 meter square. So now for the volume, we will multiply this cross-section area with the total length. I think that was 4, yeah. So that's going to be, that is 0.74424 meter cube, divided in liters. So for that, we times it by 1,000. 1 liter is 1,000 meter cube. So that's going to be 742.4 liters. Nearest integer would be 742. Okay. So 0.7424 times 1,000, which is 742.4 liters. So 742 liters is your answer. Question 4 says the diagram shows a sector of a circle that is made by a cone by joining OA to OB. The sector angle is x degrees and the radius of the sector is 7.5 centimeters. The base radius of the cone is 1.5 centimeters. Calculate the value of x. So 1.5 is basically your radius, and we are joining OA to OB to make this cone. So if you find the circumference of the base of the cone, that is basically the same as the arc length AB. So circumference is going to be 2 pi r, where it's 2 pi times 1.5. So 3 pi equals to 9.42. That is your arc length AB. So using that arc length, we can find the angle. So 9.42 equals to x over 360 times 2 pi, r is 7.5. So 2 times pi times 7.5 divided by 360. So that is 0.1308x. So then we do 9.42 divided by 0.1308, and x is coming out as 72.02 degrees. That is your angle x. Then part B says the diagram shows a cylinder with radius 8 centimeters, side is sphere with radius 17 centimeters. Both ends of the cylinder touch the curved surface of the sphere. Show that the height of the cylinder is 30 centimeters. So we have to show that the height of the cylinder is 30. So if the radius of the cylinder is 8 and the radius of the sphere is 17. This outside part would be 17 minus 8, which is going to be 9. This is 9. We just make a triangle over here. This is right angle triangle. You have to show that the height is 30, so that means this would be 15. This would also be 17 because it's the radius going towards the circumference. And we can use that. Yeah, we can use that instead. So let's use this triangle over here. This is 17 because coming from the center and going towards the circumference. So let me just remove this so that there's no confusion. So using Pythagoras, we can find the height. 17 squared minus 8 squared equals to x. Let's call this x squared. So that's going to be 17 squared minus 8 squared, 225. Take the square root of that. That's 50. So height is going to be twice of x. That's 2 times 15, and that is 30 centimeters. That's your height. Then it says calculate the volume of the cylinder as a percentage of the volume of the sphere. So volume of the cylinder would be radius was 8, height is 30. So pi r square h, where pi times 8 squared times 30, which gives us 1920 pi. Then for this sphere, the volume of sphere, we do 4 over 3 pi, r was 17 cube. So that's going to be 17 cube times 4, 19,652 over 3 pi. Calculate the volume of the cylinder as a percentage of the volume of the sphere. So the percentage is going to be 1920 pi divided by 19,652 pi over 3 times 100. The pi's will get cancelled out. So 1920 divided by 19,652 divided by 3, 0.2935 times 100. So that's 29.35%. That's your answer. And part C says the diagram shows a solid sphere with radius 6 centimeters inside a cube with side length 20 centimeters. The cube contains water to a depth of 15 centimeters. The sphere is removed. Calculate the new depth of the water in the cube. So to find the new depth, first we need to find the volume of the water in the given condition. So it's a cube with side length 20, so that means this is 20 and this is 20. So volume right now would be 20 times 20 times 15. Volume of water with sphere. So that's basically 6,000 centimeter cube. Now, when this sphere is removed, the sphere has radius of 6 centimeters. So volume of sphere would be 4 over 3 pi 6 cube. That is equal to 904.78 centimeter cube. So volume of water is going to be the difference between these two, which is 5,095.22 centimeter cube. So for the depth of the water in the cube now, we do 5,095.22 equals to 20 squared times x, x being the new depth. So we divide the two sides by 20 squared, and x would equal to 12.7. So 12.7 centimeters is the new depth of the water in the cube. Question 5 says AC is a right angle triangle. B is on AC and BC is 54.5 meters. AD is 83.2 meters and the angle ABD is 38 degrees. Calculate angle ACD. This is what they're asking us to calculate. So to find this angle, we can first find this length over here, which is going to be done using SOHCAHTOA. We'll use tan because we need the adjacent. We have the opposite. So tan 38 equals to 83.2 divided by AB. So AB is 83.2 over tan 38, which is equal to 106.49 meters. So now AC is going to be 106.49 plus 54.5, which is going to give us 160.99 meters. So to find this angle, we'll use tan again because we have the opposite and the adjacent now. So tan theta would be 83.2 divided by 160.99. So let's take the tan inverse of this fraction. And that is going to give us a value of 27.3 degrees. That's your answer. Then part B says EFG is a right angle triangle. A circle can be drawn that passes through the three vertices of the triangle. On the diagram, mark the position of the center of the circle with a cross. Explain how you decided. So center would be the middle of F and G. Why? Because angles in a semicircle equal to 90 degrees. So center would be the midpoint of FG. That's your answer. Then part C says in triangle LMN, the ratio of angle L is to angle M is to angle N is 4 is to 5 is to 6. In triangle PQR, PQ is 6 centimeters, PR is 4 centimeters, and QR is 5 centimeters. Calculate the difference between the largest angle in triangle PQR and the largest angle in triangle LMN. So we can first find the measurement for the angles in LMN. Since the sum of angles in a triangle equal to 180, so angle L is going to be 4 over 15 times 180, which equals to 48 degrees. Then angle M will be 5 over 15 times 180, which is 60 degrees. And lastly, angle N is going to be 6 over 15 times 180, which is going to give us 72 degrees. These are the measurements of angle LMN using the given ratio. And the reason is, and the concept that the sum of angles in a triangle equal to 180 degrees. Now they have given us the measurements for the triangle PQR, which are 6, 4, and 5. So for triangle PQR, the largest angle will be that angle which has the largest length on its opposite side. So that's angle R. They want the difference between the largest angle in PQR, so that's angle R, and the largest angle in triangle LMN, which is angle N. This one. So you need to find the difference between these two. So to find the angle for triangle PQR, we will use cosine rule because we have all three lengths given. So that meets the condition for the angle formula of cosine rule. So cos of R would be 4 square plus 5 square minus 6 square divided by 2 times 4 and 5. That's going to give us 0.125. So R is going to be cos inverse of 0.125, which is, so now the difference is going to be 82.8 minus 72, which is 10.8 degrees. That is the difference between both the angles. Question 8 says the diagram shows a solid formed by joining two hemispheres and a cylinder. The radius of the large hemisphere is 5.4 centimeters. The radius of the small one is 3.6, and that is the same for the radius of the cylinder. The height of the cylinder is 6.5 centimeters. Height of the cylinder is 6.5 centimeters. Show that the volume of the solid is 692 centimeter cube, correct to the nearest cubic centimeters. So we need to find the volume of the top hemisphere, the bottom one, and the cylinder in the middle. So this is V1, V2, V3. So V1 is going to be 2 over 3 pi, because sphere is 4 over 3, so hemisphere is 2 over 3, pi r cube. So that's 3.6 cube. V2 would be pi r 3.6 square times h 6.5, and V3 2 over 3 pi times 5.4 cubed. So let's find the values for all these volumes. This is 97.7. This is 264.6. That's 329.7. So centimeter cube for all three. So now total volume will be the sum of these three. 97.7 plus 264.6 plus 329.7. That's going to give us 692 centimeter cube, as shown in the question. Then it says a mathematically similar solid is made of silver. In this solid, the cylinder has a radius of 0.6 centimeters. 1 centimeter cube of silver has a mass of 10.49 grams. Calculate the total mass of this silver solid. Since they're mathematically similar, so if you look at the cylinders, 0.6 is the radius of the new cylinder and 3.6 is the radius of the old cylinder. So if we cube it, that is going to equal to the volume that we're trying to find divided by the volume of the old one, which was 692. So 0.6 divided by 3.6, and we cube that, and we times that by 692. That gives us 3.20 for the volume. So mass is going to be 10.49 times 3.20. 33.6 grams. So basically, since they were similar solids, we can use the concept for the volume of similar solids where the cube of the ratio of the lengths equals to the ratio of the volumes. So 0.6, which is the radius of the shape made from silver, and 3.6 is the radius of the old cylinder. So their ratio being cubed equals to the ratio of their volumes. So volume of the new solid divided by the volume of the old one. Rearrange it to make the new volume the subject, and that gives us 3.20 as the volume of the solid, and then times that by the mass, and that gives us the entire mass of this silver solid. Then it says AOB is a sector of a circle center O. AO is 10 centimeters and the sector angle is 216. Calculate the length of the arc of this sector, giving your answer as a multiple of pi. So length of the arc is going to be 216 divided by 360 times 2 pi and r is 10. So 2 ones are 2. That is going to be 180. The 0 gets cancelled out, so 10 is gone. So now it's 216 over 18. So 216 divided by 2 is 108. This is 9. And 108 divided by 9 is 12. So 1, 12. So 12 pi is our arc length for this sector. Then it says a cone is made from this sector by joining OA to OB. Calculate the volume of this cone. So to calculate the volume of the cone, firstly, length of the arc is basically going to be our circumference of the circular base. And our slant length is going to be this 10 centimeters. So what we need to figure out is the perpendicular height and the radius. So for the perpendicular height, let's draw half of the cone over here. Let's draw the entire thing actually. This is basically a cone. This is 10. The arc length is your circumference of the circle. So 12 pi equals to 2 pi r. So 6 equals to the radius. So this is 6 centimeters. So we can easily find the height using Pythagoras. 10 square minus 6 square equals to 8 square. So that's 100 minus 36 square root, which is going to be 8 centimeters. So volume of the cone is going to be 1/3 pi r square h. 36 times 8 times pi divided by 3. 301.59 centimeter cube. That's your answer. Question 22 says ABCD is a rhombus with the side length 13.6 centimeters. Angle ABC is 41 degrees. BAC is a sector of a circle with center B, and DAC is a sector of a circle with center D. Calculate the shaded area. So BAC is a sector of a circle with center B. So if we draw these separately over here, this is our one sector, and this is our other sector. B, A, C, and D, A, C. So for BAC, it's 13.6. Since it's a rhombus, all lengths are going to be the same, and opposite angles are going to be equal. So they're basically identical sectors. They want us to calculate the area of the shaded region. So if we draw a line over here, and we can see that we have two triangles, triangle ABC and triangle ADC. So we can easily find the area of these triangles. Area of triangle ABC, 1/2 times 13.6 square times sine of 41. That's going to give us 60.67 centimeters square. So this is also the area of triangle ADC. The area of triangle ADC is also 60.67 centimeters square. Now for the sector, we can find that as well. Area of sector ABC, which will be the same as ADC. So that's 41 over 360 times pi times 13.6 square, which gives us 66.18. So that's also the area of sector ADC. Now to find the area of the shaded region, we need to get rid of this white part. So from the area of the sector, if we subtract the area of the triangle, that leaves us with this white part over here. That will leave us with this one. And for the other, if we subtract the area of the triangle ADC from the sector ADC, we get this one. Basically, we subtract the area of the sector and the area of the triangle. Whatever value we get, if we times it by 2, that gives us the area of the unshaded part. So when we subtract that by the area of the rhombus, or the area of the triangle times 2, that gives us the shaded area. So I know it sounds weird, but like, let me show you. So first we do unshaded area, that is 66.18 minus 60.67. That is going to give us 5.51. Now total unshaded area would be 5.51 times 2, which is 11.02 centimeters square. Now for the shaded area, I need to remove this over here. Shaded area is going to be twice of 60.67 minus 11.02. That's 110.32 centimeters square, which is your total shaded area. So once again, I found the middle area by subtracting the area of the sector and the area of the triangle, times that by 2 because it was the same for the part above the line, below the line. And then I found the area of the rhombus by multiplying the area of the triangle by 2 because once again they were identical. And then we subtracted the area of the rhombus from the area of the white part. That gives the total shaded area. Question 3 says diagram shows a cylinder containing water. There's a solid metal sphere touching the base of the cylinder. Half of the sphere is in the water. The radius of the cylinder is 12 centimeters and the radius of the sphere is 3 centimeters. The sphere is removed from the cylinder and the level of the water decreases by 8 centimeters. Show that H is 0.125. Since half of the sphere is in the water, that means we need to find half of the volume of the sphere. So volume of hemisphere basically. That is going to be 2 over 3 pi r cube, so 3 cube, which equals to 56.55. Then volume of cylinder with the depth given, that's going to be pi 12 square times 3. 1357.17 centimeter cube. So when the sphere is removed from the cylinder and the level of the water decreases by 8 centimeters. So we subtract the two volumes, so that's 1357.17 minus 56.55, and that would equal to pi r square times the height. So 1357.17 minus 56.55, 1300.62 equals to 144 pi h. Divide the two sides by 144 pi, and that gives us the height as 2.87 centimeters. So to show by what level it's decreased by, we subtract 3 and 2.87, and that equals, let's keep it as 2.875. So that would give us 0.125 centimeters as shown in the question. Part B says the water in the cylinder is poured into another cylinder of radius r centimeters. The depth of the water in the cylinder is 18 centimeters. Calculate the value of r. So the water turned out to be 1300.62 equals to pi r square, and the depth is 18. So we just divide this by 18 pi and then take the square root on both sides. That's 4.79 centimeters. That's the value of the radius. Next question. The sphere is melted down and some of the metal is used to make 30 cubes with edge length 1.5 centimeters. Calculate the percentage of the metal not used. So for this sphere, the volume was 4/3 pi r cube, r being 3. So that gives us 113.09 centimeter cube. So if it makes 30 cubes with edge length of 1.5 centimeters, volume of 1 cube is going to be 1.5 cube, which equals 3.375 centimeter cube. So now volume of 30 cubes is going to be 30 times 3.375, which is 101.25 centimeter cube. So they want the percentage of the metal not used. So metal not used is going to be the difference of the volume of sphere and your volume of cubes. So that's going to be 11.84 centimeter cube. So percentage would be 11.84 divided by 113.09 times 100, which equals to 10.47%. That is going to be your answer.